There are only red and sweets and yellow sweets in a bag. 2/5 of the sweets are red. Write down the ratio of red sweets to yellow sweets. So if 2/5 of the sweets are red, then 3/5 must be yellow. So if we write it out like this, it's a little bit easier to see. 2 out of 5 piles of sweets are red, and 3 out of 5 piles of sweets are yellow. The ratio of red to yellow would therefore be 2 to 3, because it's out of 5 altogether. For question 4, on the grid, complete the diagram of a parallelogram. Now, a parallelogram has 2 sets of parallel sides. So parallel means they're never ever going to meet. So this side here would need to be parallel to this side, and that means the steepness has got to be exactly the same. So because this one goes up 1 square over 3, this one has to go up 1 square over 3, like this. And this line is parallel to this line. Same with this one. It's got to be exactly parallel, same steepness. So that one is going to look like that. And you've got 2 parallel sides here, and you've got 2 parallel sides here. That's a parallelogram. The first term of a sequence of numbers is 18. The term-to-term rule is to add 6. Is 603 a term of this sequence? You must explain your answer. Now let's do out the first few and see what happens. 18 add 6 is 24. When we add 6, we get 30. And what's going to happen with this sequence is that it's only ever going to be even numbers. Because we're adding 6 and adding 6, when we add an even number to an even number, it stays even. 603 is an odd number, so it's not going to be in the sequence. So we're going to say no, because the sequence will only ever have even numbers. Even, add even, stays even. So if we're adding 6, it's always going to stay even every time. For the second part, it says Rizvi says no terms of the sequence are multiples of 7. Give an example to show that Rizvi is wrong. So we've started doing the sequence out here. Let me copy it down here for you. 24, 30, 36. The next one would be 42. And just keep going. Now, already I've got to 42. And 42 is a multiple of 7. Remember, a multiple is a number in its times table. So 42 is an example where he's wrong, because 42 is 6 times 7, which is a multiple of 7 because it's in the 7 times table. A road map has a scale of 1 to 50,000. That means that 1 centimetre on the map, or 1 metre on the map, is 50,000 centimetres or 50,000 metres in real life. Real life is 50,000 times bigger than the map. Okay, the length of a road on the map is 8.5 centimetres. Work out the length of the real road in kilometres. Now, this ratio has no units, so that means that 8.5 centimetres on the map is 1 centimetre on the map is 50,000 centimetres in real life. So 8.5 centimetres on the map, we need to times that by 50,000 to get the real life. So we're going to do 8.5 times 50,000, which is 425,000 centimetres. However, that's in centimetres, not in metres or kilometres, and kilometres is what we need in. So first, let's put it into metres. To go from centimetres into metres, well, 100 centimetres is 1 metre. So we're going to divide that by 100, and that is 4,250 metres. And 4,250 metres, we still need to get that into kilometres, and every 1,000 is a kilometre, so that's going to be 4.25 kilometres. I've divided it by 1,000 to get it into kilometres, so that's 4.25. Question 10. Uzma is planning a party for 120 children. She's going to give every child a toy. A pack of 8 toys costs £4.35. Work out how much Uzma will have to pay for the toys. So she can buy 8 in a packet. First thing we need to do is work out how many packets is she going to need to buy. There's 120 children, so how many 8s make 120? So let's start by doing 120 divided by 8. And you could do that using the bus stop method. 8 into 1 doesn't go. Carry it over. 8 into 12 goes once, remainder 4, and 8 into 40 goes 5 times. So she needs to buy 15 packets, and 15 times by £4.35. And we've got a calculator, so let's go ahead and use it. Just make sure that everything you type in your calculator, you're also writing on the page to get those method marks. And that is £65.25. Work out the value of, and then we have this, and we need to give our answer correct to 2 decimal places. Now we're just going to type this exactly as it is in our calculator. Now it's a 3-mark question, so normally you're going to get a mark for the numerator correct and a mark for the denominator being correct, and then a mark for the overall answer. I'm going to put it all in though in one sum. So first I press my fraction button, which is here, and then I'm going to press the square root 2.7. Now, if I just type add there, it's going to continue putting the next bit in the square root, but I don't want the 6.5 to be in the square root. So I need to press the right-hand arrow to come out of the square root and then plus 6.5. And I'm going to do that over 4.8 minus 1.06. So my answer is 2.177317,559, but we were told to 2 decimal places. There's your first decimal place. There's your second decimal place. So we want the number to end there. Check the next number which rounds up. So it's going to round this number up to an 8. So 2.18 is your final answer. Now, we want to, however, make sure that we're getting some marks here. This is a 3-mark question. If this was wrong, we'd get no marks. So let's go back and just write them out separately. So I'm going to do root 2.7, add 6.5. For the numerator, press the SD button, 8.143167, blah, 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 over, and now let's do the denominator, 4.8 minus 1.06, which is 3.74. And let's just double check. 8.143167 divided by 3.74 is, and we're getting that same answer. Okay, 2.17. Getting the same answer by doing it like that. So you're going to get yourself the most marks by just doing everything separately, doing it together, and double checking you get the same answer. For the second part, for question 14 even, 3/8 of the people at a football match are men, 27% of the people at the match are women, the rest of the people at the match are children. Work out what percentage of the people at the match are children. Now, slight problem, because I've got a fraction and I've got a percentage. So what we're going to do is try and make them the same. Now, I don't mind if you try and make the percentage as a fraction and add them together, or if you try and make the fraction as a percentage. I'm going to go for percentages because my answer needs to be a percentage. So let's make them all percentages. If in my calculator I type 3/8, I get 0.375. I've just typed the fraction here, 3/8. And that's got 0.375. And then I'm going to times that by 100 to get that as a percentage. And you'll see that that's 37.5. So the men is 37.5%. The women is 27%. And the children's going to be the rest. So let's add 27. We'll add those two together and we get 64.5. And then I'm going to do 100%, take away 64.5, and that is 35.5%. And that's my final answer. Okay, quite a lot of words in this question. First thing we're going to do, in September, Sharon paid £565 for some books. She sold all the books for a total of £780. So first thing I've done is worked out how much money she made, £215 profit. In October, Sharon bought and sold some more books. The total profit she made in October was 13% more than the profit she made in September. So we're going to do 13% more than 215. So I'm going to take 215 and I'm going to times it by 0.13, and that's going to get me 13%. So 215 times by 0.13, because 13% as a decimal is 0.13, and that is £27.95. So that's going to be the extra profit that she got in September. In November, she wants to pay a bill of £30. She thinks that the 13% extra profit she made in October will be enough to pay the bill. Well, no, she's not right. So no, it isn't enough. £27.95 is less than £30. So sadly, she's not made enough money. Write an integer in the box to make the statement true. So 2/7 is greater than, so this is the bigger side, and this has got to be smaller than 6/something. Now, if we use equivalent fractions, we know that 2/7 is the same as 6, we've times the top by 3, so we need to times the bottom by 3, over 21. So if we made it 21, they would be the same. How am I going to make this side smaller? Well, if I want to make a fraction smaller, I need to make the denominator bigger. Imagine a cake, and if I share it with one other person, if I just divide it by 2, we each get half of the cake each. And the more people we start sharing the cake with, the smaller our slice of cake becomes. So if we make this number bigger, we're sharing it by more people. So we're going to make the overall thing smaller. So as long as you use a number that's bigger than 21, 22, 23, 24, any of those, then the fraction is going to be smaller. If we take 6 and we divide it by 100, for example, that's definitely going to be a lot smaller. So why is that true? Because 6/21 is equal, and dividing it by more makes the answer smaller. The diagram shows a shape made by overlapping 2 identical squares. The area of the shaded region is 25% of the area of each square. So this is 1 part, and this is 3 parts. 1/4, 3/4, and then this is 1/4 and 3/4. So you could do it out of 4 if you like, but actually it's easier if we just say this is 1 area, and whatever this area is, this is 3 times bigger, because this is 1/4 and this is 3/4, and the same on this one. This is 1/4, this is 3/4. So altogether, it would be 1 out of 1, 2, 3, 4, 5, 6, 7. So 1 out of 7 would be our answer. Now, if you wanted, you could give it an area. You could say, okay, I'm going to say that this area is 10. And if that area is 10, then that area is 30, because it's 1/4 and 3/4. And the same for this. And then you might get 10 out of 70. And you could simplify it to get 1 out of 7. No matter what, though, just if you're not sure, give it a number, work it out, and then compare that as the whole. Here's a number line. On this number line, show the inequality -2 is less than or equal to x, which is less than 3. So we need to put a circle above 3, and we need to put a circle above -2. This is how we're going to show that inequality, and we join it up with a line. And that shows someone that the numbers that are allowed are in between 3 and -2. If it's just one number that you're given, you just do an arrow. But because we've got a top number and a bottom number, we do a circle above each, and we join it up with a line. Now, it's equal to the -2, so that means we can actually have -2. We can have -1, 0, 1, and 2. We can't have 3 because it doesn't equal 3, but it does equal -2. And the way we show that is we colour it in. Now, I was taught at school to imagine a little man on the line, and he's got a pen. And if he can reach it to colour it in, then it's equal to it. And that helped me remember that if it's equal to, we colour it in. And if it's not equal to, we leave it blank. We now have to solve the inequality 2n add 3 is greater than 27. And this is the same as an equation. And I like to use a dotted line to show the middle of my equation. What we do on one side, we do on the other. So the first thing I'm going to do is take away 3 from both sides. So all I'd be left with on this side is 5n. We've taken the 3 away. And on this side, I'd be left with 24. And that needs to be bigger than. Okay, just keep that sign coming down. Then we've got 5n. I don't want 5 lots of n. I just want 1 lot of n. So I've divided this side by 5. I've got to divide this side by 5. And 24 divided by 5 is 4.8. You can use your calculator for that. So n must be bigger than 4.8, so that 5 lots of the same n add 3 is bigger than 27. And that's our answer. So n is greater than 4.8. We must write the n and the inequality on the answer line. You can't just put 4.8 on the answer line, because 4.8 on the answer line doesn't tell me if it's bigger than 4.8, less than 4.8, or equal to 4.8. So that inequality has to go with it. Describe fully the single transformation that maps triangle P onto triangle Q. Now there's 4 transformations. There's rotation, reflection, enlargement, which is where it's made bigger or smaller, and translation, which is when it's just moved. It stays the same way up, it just moves somewhere else, okay? Now, if you're asked for a single transformation, you need to pick one of those words and one of those words only. Single transformation means only one of these things has happened. And as soon as you write it's a rotation and then a reflection, you're going to get no marks whatsoever, because it looks like you've written 2 answers on your answer line. So we're just going to pick one of these. And in this case, it is rotation. It's turned. But if you write turned, you're not going to get the mark. You must say it's been rotated. So we're going from P to Q, and it's turned and it's gone that way. This is going to be a 90-degree rotation, and it's anti-clockwise. Okay, the clock would go this way, and we've gone this way, so it's anti-clockwise. So shape P has been rotated 90 degrees anti-clockwise around the point. Now, we have to have the spin point there. It's called the center of rotation. So around the point. Now, normally it's the origin, and in the exam you'd have tracing paper. And you're going to put your tracing paper over the top, and you're going to put your pen on the point. I always try the origin first. Draw around P on your tracing paper, and then spin it and see if it lands on Q, and it won't on that point. Actually, it's going to be this point here. Okay, and we can see if you go across 2 and up 2, and then you go up 2 across 2, that's how you're going to spin that line. You're going to get to that shape. But use a tracing paper in the exam. Ask for tracing paper, or you should have it on your desk. Put it over the top, put your pen in the middle, and then spin it. Okay, so it's around the point, this coordinate here, which is 0, minus 1. So we're told the perimeter is 28, and the perimeter is the distance all the way around the outside of a shape. I know that this is 6, because I've got 2 here and 4 here, and that adds together to make 6. And I know that this bit here is 3. And if you add all of that together, 4 add 2, add 3, add 6, add 3, we get 18. But we know that all the way around the outside is 28. So that means that this bit here and this bit here must be the extra 10. And so it's going to be 5 up here and 5 down here. So I've got 28 minus 18, which is 10, and 10 divided by 2 is 5. Now we've got to do the area of the grey bit. Now, can't work out the area of a funny arrow shape, but what I can do is the area of the whole thing, and then I can do the area of this triangle, the area of this triangle, and take it away. So the area of the whole thing, let's split it into 2 rectangles. This rectangle here is going to be 3 times 6, which is 18, and this rectangle is going to be 5 times 4, which is 20. So the area of the whole shape is 38. Then we want to do the area of the triangles. So the area of this triangle would be 6 times 3 divided by 2, which is 9 centimeters squared. And the area of this triangle is 8 times 4 divided by 2. We always divide by 2 for a triangle. So 8 times 4, which is 32, divided by 2, which is 16. So I've got 16 for this triangle. I've got 9 for this triangle. And if we add those together, it's 25. 38, take away 25, is 13. So that's my final answer. The area of the grey bit must be 13 centimetres squared. And last but not least, we have a graph. This graph says we're going to draw y equals 3 divided by x. And we've got some values to fill out. So to get y, we need to do 3 divided by x. So I'm going to use my calculator. I'm going to do 3 divided by a half. And 3 divided into halves actually doubles. So 3 divided by a half is 6. 3 divided by 3, which is 1. 3 divided by 5, which is 0.6. And 3 divided by 6, which is a half. So I'm going to put 0.5 here. Once you've done that, you've got all your coordinates. So the first coordinate is 0.56. We're going to go across to 0.5, and up to 6. Then we're going to go 1, 3, that's the next coordinate. Then we're going to go 2, 1.5, 3, 1, 4, 0.75, 5, 0.6, and 6, 0.5. And join it up with a smooth curve. And that's what your graph should look like.